We're going to solve this problem using dimensional analysis, and then I'll go over why, the reason behind why 1 degree Celsius is equal to 1.5 degrees Fahrenheit. All right, so I just gave you the equivalence, all right? So we don't know what the conversion factor is, but I'll write that down. That's the two equivalent measurements. So 1 degree Celsius is equal to 1.8 degree Fahrenheit. All right, we're going to use that, I'm sure, somehow in our conversion factor to do whatever it's asking us to do. All right, so if the temperature increases by, all right, so already, there we go. That's our beginning value, 48.0 degrees Celsius. All right, I already know it's going to ask us for Fahrenheit. It is, and we are going to set up the conversion factor to cancel out Celsius and end up with Fahrenheit. Very straightforward problem. Make sure this conversion factor is equal. It's a ratio of equal measurements. So 1.00 Celsius goes there, 1.80 goes up there. Cross out the units, just good habit. So just multiply 48 times 1.8, and we get 86.4. And don't forget your unit. That's the only unit left in our work. So that is going to be your final answer. Check the sig figs. You got 3 in your measurement, 3 in your final answer because you're multiplying and dividing. So let me explain why we have that that equality of 1 to 1.8. So this is let's say this is the Fahrenheit scale. Let's say that's a thermometer in Fahrenheit. This is a thermometer in Celsius, and we'll use the standard comparison to water. The boiling point of water, the boiling point of H2O on the Fahrenheit scale is 212, and on the Celsius scale is 100. And the freezing point of water, FP of H2O, all right, and that's water freezes at 32 degrees Fahrenheit and 0 degrees Celsius. So go ahead, take a moment and see if you can see where the 1 to 1.8 is coming from. All right, so if you take the difference, switch the color up a little bit. If you take the difference here, it's pretty easy to see that that's 100 increments between the freezing point and the boiling point of water. You could take any 2 points, but this is just it's just convenient to use the boiling point and freezing point of water. All right, so there's a 100-degree difference in the Celsius scale, and if you just subtract that, the 2's are the same, so it's 21 minus 3 is 18, and then you add that 0, it's 180 degrees between the same 2 points. So freezing point to boiling point, right, arbitrary, these are just scales that we made up, but the difference is 100 to 180. So doesn't matter what you want to put on the top or the bottom of this if you want to make a ratio. So it's going to be like 100 degrees of Fahrenheit is equal, right? You can see that because they're equal distances from the freezing point and boiling point. All right, so is 180 Fahrenheit is equal to 100 Celsius, and that's where we get the 1.8 to 1.00. Now you could have flipped this around. I just picked Fahrenheit on the top because I happen to write it first, left to right. All right, we can reduce that, and that'll be 9 degrees Fahrenheit to 5 degrees Celsius to simplify that. Now, if you want to convert one scale to the other, you have to not only consider the scaling difference, which is 9 to 5 or 5 to 9, depending on how you're looking at it, but there's also, they don't start at the same point, right? Like this one starting 0, this one starts at 32. So there's a 32-degree shift that's involved. So that this conversion is a little bit trickier than the Celsius to Kelvin. All right, so let's put this together and give you some formulas if you want to just memorize this for fun. All right, so therefore, if you want like the Celsius scale, right, you take the Fahrenheit value. All right, what are we going to do? Fahrenheit is 32 above Celsius, right there. So we're going to have to subtract to get Celsius. To get to Celsius, we're going to have to subtract 32 degrees to get to that, to take care of that shift, and then we multiply by that by that scaling difference in a way to get rid of Fahrenheit, right? So now remember 9 degrees Fahrenheit is the same as 5 degrees Celsius, so that'll get rid of the Fahrenheits. You know, you got to multiply through, and then you'll end up with Celsius. Now, you can also do the same thing and get the Fahrenheit given Celsius, right? So what do you think? Okay, what we're using the scale. Do we put we're going to multiply this by the scale and then add the shift. So we're going to put the Celsius on the bottom, right, to cancel that out and end up with Fahrenheit. So the scale is 9 to 5. All right. And then you've got to add the 32 to shift it back in place after you scale it. All right, so yes, I don't know how often you're going to see this kind of problem, but since they brought it up here without explaining why it's this ratio, 1 to 1.5, I figured I'd give you that